All right. So today we'll be focusing on pin mapping for Raspberry Pi Pico home security device. And basically, my name is Dr. Lakune Elijah. I've introduced myself in previous series. So in case I just joined it for the first time, so just a little bit about me again. So I'm a researcher, author, lecturer, also a founder. Um, my research interest lies in the area of Internet of Things, artificial intelligence, embedded systems, signal processing, wireless communication. So this is my Google profile in case you are interested to see some of the works I'm doing. Okay. So for today, basically, I'll be focusing on three main items. One is looking at the Raspberry Pi Pico pin configurations. So we'll look at some of the features of the Raspberry Pi Pico. Then we'll look at our home security design, which we started last week in our last webinar. And I will discuss more on the pin mapping, basically how you connect your components to your Raspberry Pi Pico. Okay, so let's start with the Raspberry Pi Pico pin configuration. And for us to be able to look at the pin configuration, first we need to look at some of the features that the Raspberry Pi Pico-w has. So we're looking at Raspberry Pi Pico-w. Remember in our first webinar that different variants of the Raspberry Pi Pico. We have the Raspberry Pi Pico, Raspberry Pi Pico-w, and Raspberry Pi 2 and Raspberry Pi 2 Pico-w, right? So today we're just focusing on the Raspberry Pi Pico-w. All right, so basically it has the RP2040 microcontroller on board with 2 MB of flash memory, okay? So the Pico-w supports the single band 2.4 gigahertz wireless interface. That's the 802.11n. So that's what allows us to do some IoT projects in case we want to do IoT projects, okay? It supports micro USB ports. So that's why when you want to program, once you plug in your Raspberry Pi Pico to your system, it appears as an external drive. So this is the feature that enables it to do that. Then it has a 40 pin, okay, 21 by 51 mm. All right, that's the size. Then it has 26 exposed multifunction 3.3 volt general purpose input output pins. Okay, out of these 26, 23 of them are digital only, while 3 are used for analog to digital converter, okay, ADC. Others are some of these features, which I think we'll just move on to the next slide, so you can read that up later on. So if you want more details about the features of the Raspberry Pi Pico-w, there's a link here in the slides. So hopefully I will share the slides after this particular webinar. So you can go and look up the other features of the Pico-w. Now, let's look at the pin configuration in terms of power pins. First, we need to know what all of these pins stands for. First is the VBus. So the VBus, this is the power from the micro USB. So if you power your Pico-w from your USB port, automatically you have a 5 volts that's been supplied that can be used to power any of your components, okay? So if the Pico is not powered by the micro USB connector, then there will be no output power here. There will be no output voltage on this particular pin. So take note of that. The VSYS, okay, this is the input voltage. So let's say you don't want to power your Pico-w microcontroller board with your USB. You can connect your own 5 volts DC power supply to this particular pin, right? So in that case, every component that you'll be connecting to your Pico-w must be powered using that external power supply. Otherwise, if you connect your components to this particular VBus and you supply your power through here, then your components will not have power. It will only have power if you connect through your USB. Then this is the ground. We have about 8 pins on the ground. So we have 8 different pins. So you can use any of the ground pins. So you can see the shape of the ground pins is quite different from other, like a rectangular box. Right, this is like a oval shape. Okay. Next, we have the 3 volts 3 enable. So this is if you are trying to control your power output from your Pico-w. So you could switch it off using your 3.3 volts enable. All right. Then the 3.3 volts out. So this particular pin supplies 3.3 volts to any electronic components you wish to connect to your Raspberry Pi Pico that requires a 3.3 volts. So example is your OLED and all of that. All right, so this all for about our power pins. Then let's look at more. So I think I've spoken about this. Then the run pin, there's a run pin there. Yeah, in this line can enable or disable the RP2040. Let's say you want to reset, you want to create a reset button whereby in case your microcontroller hangs or freezes, so you can create a reset button on your device. So you connect it to the run pin. I think the run pin is one of these or this. I can't remember now. All right. So let's move on quickly. So we have other pins like the ADC. All right. So we have, if you can see, ADC 2, ADC 1, ADC 0. So these are part of the 26 GPIO pins that are available for you to use. So if you're using your ADC, that is GP28, ADC 1 is on GP27, and ADC 0 is on GP26. So if you have any analog device, so some devices comes as analog output and digital output. So like this particular gas sensor, you can see it has A0. A0 stands for analog output, and D0 stands for digital output. D0 means it will just send a signal, whether either a high signal or a low signal. So if it detects gas above a particular threshold, it sends a high signal. If not, it will send a 0. While for analog, it gives you the equivalent of the values in voltage, maybe from 0 to 1.1, 1.2, 1.3, and all of that up to the highest in voltage. So in that case, you may want to use analog or digital. Bear in mind, if you are using your GPIO pin, you can either configure it as digital or as analog. So you cannot use it for both at the same time. All right, so let's move on. So other pins are the interfaces. So you have things like the UARTs, Universal Asynchronous Receive Transmitters, okay? You have things like the SPI, Serial Peripheral Interface. You have things like the I2C, that is Inter-Integrated Circuit, okay? Then pulse width modulation channels, all right? The USB 1.1 feature peripheral that allows you to save your files on your Raspberry Pi Pico-w. Then we have this, what they call the programmed input output, PIO. All right. So this, if you want to design a communication protocol for your own communication protocol, you can program these PIO pins for that purpose. So let's say, for example, you want to create a driver for your light displays. So you can program it yourself. So what happens is it uses state machines. It will not use the CPU of your microcontroller. All right. So it's usually very fast, faster than using the CPU. So if you have a dedicated protocols you want to create or work on, you can program this. This is what distinguishes this particular microcontroller from most microcontrollers you have of. All right. So let's look at the part 2, which is the home security design. All right. So last week we talked about it. Say we want to design a home security device. We're monitoring one window, one door. We looked at some of the sensors we could use: magnetic switch, PIR motion sensor for detection of movement. We want to set up an alarm, a display system that tells us what is happening, a local storage that saves the timestamps and activities of intrusion, power management, using battery backups or low power mode. Then, of course, for connectivity, Wi-Fi, in case we want to set up an Internet of Things home security device. So we saw the block diagram. So we have a microcontroller to different sensors. So window sensor, door sensor, alarm system, motion detector, OLED display, the ROTC module, SD card module, and the power supply. Okay, so this is the block diagram, right? Now, in terms of circuit diagrams, so this is where it gets complicated if you don't have knowledge of electronics, okay? And that is why the pin mapping is very, very important. So which of the pins are you connecting to your Raspberry Pi Pico? How do I know this? So that is what we are here to answer today, all right? So first, this is the old circuit diagram. So I'm going to go through them one after the other by taking each of these components, and we'll see which pin to connect to on our Raspberry Pi Pico microcontroller. So this is the pin mapping from this circuit diagram, okay? So tell me which pin to connect to which of the pins of the microcontroller. So one of the things you need to do at the beginning of your design is to create this. Well, how do you create this? So we're going to look at it step by step. So you can see in this case, your Raspberry Pi Pico GPIO pins. So looking at the GP0, GP1, GP0, GP1, connected to your OLED display and also connected to your real-time clock. Okay. So let's look at them one after the other so that we can understand better. So the first is, let's say for our OLED, okay, organic light emitting diode. So it comes in various sizes. This is the 0.9 inch, 96 inch OLED, okay. Now, some of these OLEDs come with their interface, that is the kind of protocol you need to communicate with your Raspberry Pi Pico microcontroller. So in this case, it's an I2C OLED. So when you see I2C, it's a interface protocol, a communication protocol between your components and your microcontrollers. I won't go into the theoretical part of it, but the two things you're supposed to see is the SCL and the SDA. So sometimes they call it two-wired, okay? So it uses this SCL, serial clock line and serial data line, to communicate with the microcontroller. So you first check, this is SCL, right? This is SDA. So you go to your microcontroller and identify the SDA and SCL on your microcontroller. So in this case, we have several options. So you're not, the good thing about this microcontroller, you're not tied to one GP0, one particular GP pin for your SDA and SCL. You can decide to connect to your GP0 and GP1 because SDA has GPO has SDA and GP1 has SCL. You may wish not to use this pin. Maybe you have used this pin for something else, so you don't want to use that particular pin. You can look for another SDA somewhere else. So you notice there are several SDAs. There's I2C1 and I2C0. So if you're using the I2C0, you notice there's another SDA here, so which is GP12 and SCL is GP13. So you can decide to connect your SCL to GP13 and SDA to GP12, all right? But bear in mind, if you are using any of these pairs of I2C on your microcontroller, you cannot, that is the only pair you will use throughout. If you have other I2C components, you have to make sure that they are connected to the same GP12 or GP13 of the SDA and the SCL respectively. So what do I mean? Let's say I want to connect two devices, the OLED, and let's say, for example, I have another I2C device, which is the real-time clock. I want to connect it to my microcontroller. If I've chosen my SDA to be, let's say, GP12 and my SCL to be GP13, I will connect my SDA here to GP13, SDA to GP12 and SCL to GP13. The same thing, I will come to my OLED, I'll connect my SDA to GP12 and my SCL to GP13. So no matter the number of I2C components you have to connect your microcontroller, everything will be connected to the same SCL and to the same SDA. I hope that is clear. So let's move forward a bit. So coming to real-time clock. So again, you check your real-time clock. Is it I2C protocol? Yes, it is. So you identify the SDA and the SCL. So the SDA, like I said, you select any of the I2Cs you want to use the pins and connect it just like I've explained. So you can see then the power supply, usually for some of these components, you have to check the pin configuration or the data sheet online. Okay. So some of these components are powered by 3.3 volts, while some are powered by 5 volts. If you are powered by 3.3 volts, then you connect to your 3.3 volt of your Raspberry Pi Pico, which is your pin 36. And one thing I want to point out, when you're reading the pins for your microcontrollers or your microcontroller boards, you read it anti-clockwise, starting from GP0, you can see pin 1, 2, 3 to 20, so anti-clockwise. So this has 40 pins, right? And each of these 40 pins stand for various functions. Now let's go to the SD card, all right? So for the SD card, it uses a serial peripheral interface, SPI. So again, for the SPI protocol, it's a different kind of protocol. You need to understand how it works. So basically, you have your MISO, you have your MUSI, you have your serial clock, and you have your chip select. So again, I won't go into the theory of this, but it's something you can find online. Or maybe if I have the time, I could do a tutorial of that. So now, Having known that your SPI, you need to go to your microcontroller and check where are my SPI pins. So you can see they're all labeled SPI 0, SPI 1. Okay. Again, this gives you multiple options to say, okay, I want to connect it to a set of GP pins that has the SPI protocols. So in this case, for this particular one, so for my pin mapping, I said, okay, my MISO. So some SD card, we either call it MISO, some we call it DO. All right, some we call it MOSI, some we call it DI. So whatever it is, they are the same, MISO or DO or MOSI or DI. So I want to connect my MISO to GP12. So GP12, you can see. So GP12 says SPI 1 receive. That's the receiver, okay? Then the MOSI GP15, okay? So GP15 tells us the SPI1 transmitter, okay? Again, if you are working with the SP1s, don't mix it up with SP0s. So if you are choosing to work with SP0s, SPI zeros, select their pairs, their corresponding pairs. If you are working with SP1, select the corresponding pair. Okay. Then the chip select is GP13. Okay. So you can see SPI1, chip select, CS, like that. Then serial clock to GP14. So GP14, you can see SPI1, SEK. So with this, I know, okay, my pin mapping is done. So again, the power supply 3.3 volts can go to your 3.3 volt out, or you want to power with 5 volts, you can also power with either V bus or connect to your V system. V supply. Okay. Now let's move on to the magnetic and window sensors. Okay. For the magnetic and window sensors, it's just a general digital input pin. Okay. So it's a digital input pin. Okay, so we can have digital input or digital output. In this case, it's a digital input. Why? Because we are sensing some currents or voltages, and we are reading it in the microcontroller is reading whatever voltage or current that is coming from your magnetic sensor. So the way this magnetic sensor is made is that it has a magnet, which is this guy. Then it has a read switch. A read switch, you can check it online. So it's more like a switch. If there's a magnet, it pushes it, then it makes a contact. If not, it opens up, right? So in this case, there's no polarity. So you can connect one pure pin of the sensor to either ground, and the second pin, that's the wire one, to GP, any GP you wish to that you have not used. It could be GP8, it could be GP9, provided you have not used that particular GP, okay? So let's look at the previous, so you can see, we said the door sensor is connected to GP27 and window sensor is connected to GP22. So any of the GPs will work for it. Then the last bit, which is buzzer. So again, the buzzer is a digital output, meaning we are sending signal from our microcontroller to the active buzzer. In this case, it's an active buzzer. So there are two different types. If it's just an active buzzer, it will generate a monotone. So if you just send a 3.3 volts to it, it will sound until you stop the 3.3 volt supply. So again, you can use any of the general purpose pins, maybe GP8 or GP27, provided you have not used them before. So in this case, we're using GP28, which is this one. All right. So this is for our active buzzer. Then the next is our PR motion sensor. Again, so this has 3 pins. It has VCC, ground, and the signal. So this is going to be an input pin. We configure as an input pin to our microcontroller. So it could be any of the GP pins again. So in this case, we're looking at GP19. So it's a digital input pin. So we can use GP19. If it was an analog input pin, then we have to select either GP26 or GP27 or GP28, right? Okay, so in summary, we've looked at the pin configuration of Raspberry Pi Pico and its features. So the design for the home security, the pin mapping for the Raspberry Pi Pico microcontroller. So I'd like to open up for questions now and to see if you have questions, you can attend to the questions based on what I've just shared. If not, then I can use the remaining few minutes to elaborate more on some of the things we've talked about. So if you have questions, please feel free to mute yourself and ask your questions. Any questions from the audience? Is there any questions? While we wait for questions, so let's look at this particular circuit using our WalkMe simulator. So it's basically the OLED and a DHT22 temperature and humidity sensor. Let's say you want to do a simple project that has to do with monitoring the weather conditions or weather parameters, either for your home or for your poultry, whatever you want to monitor. So you can use these. So again, if you click, when I share the slides, once you click on it, to take you to this particular design as well, so you can go and explore it. So I introduced Walkway Simulator in our first webinar. So if you haven't used it before, so you can go. It's quite easy to use. Just register either using your, sign in using your Google account, or you sign up. Then you can go to your My Project, create a new project. So but I want to do that now. So let's just look at this simple one. So if you look at this particular design, so this is our Raspberry Pi Pico-w. So you can see our SCL is connected to GP1 because GP1 is SCL on the microcontroller pin configuration, and SDA is connected to GP0. So you can see where in the code, we have where you need to define which pins have been connected. So you can see step 2, configure your GPIO pin. I'm not sure if you can see this clearly, otherwise I can zoom out. Maybe I zoom out a bit. So if you notice, the SDA pin and the SCA pin has to be defined because we have connected them to GP0 and GP1. So it has to be defined in your codes, all right? Why the DHT pin was connected to GP16. So all of this has to be defined in the code so that your microcontroller knows which component is connected to which pin, all right? So if I run this particular example now, so just run, it's quite easy to, so you can see it's showing the temperature and the humidity. It's showing the temperature and the humidity, right? So this, if I change, you can vary the, for simulation purpose, you can vary the temperature and you can vary the humidity, all right? So do we have any questions? I think we're about to run out of time. Any questions before we round up for today? So either questions, or if there's any area you would like me to talk about in our next webinar, please
Good afternoon, Prof.
Yes, good afternoon.
Good afternoon, Prof.
Hello, Prof. Good afternoon.
Good afternoon, sir.
Yes.
Thank you very much for the wonderful webinar. Please, I have a question.
Okay.
In this code, I can see that in line 2, pin, PIN, with P capital letters.
Yes.
Whereas in line 14, DHT dash pin, the pin is with P small letter.
Yes.
Is there any difference between capital letter and small letter in this kind of programming language?
Yes, I think that's a very good question. Yes, there's difference. So if you look at first thing, you need to import some modules or some libraries, which I think I talked about it last time. So from machine import pin. So these modules are you have to follow this capital letter as per the documentation for MicroPython, right? Whereas in this DHT underscore pin is a variable that I created. So I created this one. It's a variable I created, and I assigned pin 16 to it so that I can call it at any time. So when I wanted to use it for my DHT pin, so I just substituted it. So I could do this, or I could just put pin 16 here, and it works. So this one is different from this one.
Thank you very much, sir.
Yeah. All right. So any other question? We have just a few minutes left. Okay. So I believe we all understand what pin mapping is now. So it's quite easy to use. So basically, you just need to any component you want to use. First, you need to go online, search for the particular component. So let's say, for example, I want to use DHT 11, with my microcontroller. So I'll just say pin out. So when I do pin out, it will come here and tell me some of the features. So as you can see, we have, it will show you which one is VCC, which one is ground, and which one is data. Sorry. All right. So it will tell you what's the power for that particular pin. So if it's 3.5 volts to 5.5 volts, then this gives an idea. Should I use my 3.3 volts of my microcontroller to power it, or should I use my 5 volt to power it? Okay. Then it will tell you which one is the data pin. So the data pin is the one you're connecting to your GPIO pin of your microcontroller. Okay. And it will tell you which one is ground. So basically, they come in this form. Either this is a DHT do, and of course, this is just a DHT sensor. So anyone you buy, if you have to buy this, then maybe you have to do your wiring connect by yourself. Otherwise, if you buy this module, just need to connect your wires and connect your Raspberry Pi Pico-w. Okay. So once you've done this, then everything after this is going to be development of the firmware. So next week, I'll focus more on development of the firmware. We started last week, but I'll go through step by step how you write some of the codes, just like you see here, so you understand what is happening. Why am I importing this? All right. So for the the OLED, you need this SSD 1306 library for it to work. Otherwise, it will not work. For the DHT sensor, you need this to import DHT. Why this time is for creating delays in your code. And this pin is for you to configure each of your GPIO pins. And the I2C is for you to use the I2C communication protocol. So we look at them one after the other in our next webinar. Okay, so we still have a few minutes left. Any question? If not, then maybe we'll round up here. So again, I do apologize. The network, I think around this time, it's a bit funny. It's up and down. So that's why there was some outage during the course of the webinar. So again, we try and see if we can get a better time where the network will be more stable. All right. So if there are no questions, maybe we'll round up here for today. And once again, thank you for joining. And I'll be sharing the recorded video later on and also the slides. And if you have any question after this, then you can always put it in the WhatsApp group so that everyone can learn from your questions while we try to answer as much as we can. Okay, so we'd like to end on this note. Once again, thank you, and I'll see you in our next webinar.